Question 7 is very similar to question number 6, except for this graph, we're only going to have one really decisive place from our graphical interpretation that we know. If we look at our scaling, this is the only one that really is telling us where we know it's going through. It's going through at a half. These others aren't as decisive, so we don't know where those are. We're going to have to find those through working with our synthetic division and factoring, or at least using our quadratic formula to find those other remaining two. So this one is pretty clear cut. We know one of our zeros already. It's a half. We just got to go find two more because it's a third degree polynomial. So in order to find those, we're going to set up our synthetic division. We're going to divide by half. We're going to divide it into a 2, 7, -2, and a -1. Bring down your 2 and you take half of 2, which is 1, add it to 7, which is 8, half of 8 is 4, add to -2, which is 2, half of 2 is 1, and 1 and -1 is 0. So we were at a third degree. We are already down to a second degree, which is our primary goal, because once we have it as a second degree, we can write it as 2x squared plus 8x plus 2 equals 0. Okay, now this is what we're going to solve. We have to find the zeros of the second degree polynomial, or solve it for x. So it's a quadratic equation. I'm going to go right to my quadratic formula. Actually, I'm going to take that back. I am going to factor out the 2 first, since there's a common factor of 2 out of all these. Take out a 2. I got x squared plus 4x plus 1 equals 0. And now I'm going to go into the quadratic formula. Really what I need solutions for is this quadratic equation. When is it equal to 0? Because it's not that 2. Multiplying by 2 does not make it equal to 0. So I'm going to find the zeros by using the quadratic formula, which is the -4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 1, which is -4, all over 2 times 1, which is 2. And if we simplify this, it's a -4 plus or minus the square root of 12 all over 2. And at this point, I'm going to break out my division and distribute my division by 2. It's a -4 divided by 2 plus or minus. I'm going to divide it by 2. And I'm going to break up the 4, or the 12 into 4 times 3. The reason I like 4 is because 4 is a perfect square, and we're going to be able to simplify that. So that's a -2 plus or minus the square root of 4 ends up being a 2 times the square root of 3 all over 2, and that will reduce one more time. So our solutions are -2 plus or minus square root of 3. Now solutions are zeros. So I'm going to drag those back up, -2 plus or minus square root of 3. -2 plus the square root of 3, -2 minus the square root of 3. You can break them up, or you can write it as plus or minus, so I don't mind either way. What we know is that when x equals a half, we get a 0. So now we want to just set it equal to 0 so we get our factor. So we're going to multiply times 2, so 2x equals a 1, and then we're going to subtract the 1, so 2x minus 1 equals 0. Here's our first factor that we want to put in our factor line, 2x minus 1. We're going to do the same thing with the other two. We know that when x is a -2 and we add the square root of 3, it's a 0, the function. If to get a factor, we simply move them over and get it set equal to 0. So x plus 2 minus the square root of 3 equals 0. There's our second factor that we want to include. So it's going to be x plus 2 minus the square root of 3. And our last factor, just kind of a different color here, is when we pull this one, it is x equals a -2 minus the square root of 3. But if we set it equal to 0, we got x plus 2 plus the square root of 3 equals 0. And that is our final 0 for this one, and our final factor. So it's x plus 2 plus the square root of 3.